Colby, math.com.
Okay, today we finished our a short unit on classroom culture, and tomorrow all my classes will begin the first unit, the first academic unit of the year, which gives us an opportunity tonight for the homework to take a first look at a contest that we'll be participating in February. So we're part of the Florida Community School is part of the Florida Math League, and in February schools all across Florida participate in a math contest. The contest is going to look a lot like the sheet that I gave you. You see it on the screen there. This one that we're going to do tonight for practice is from 2010-2011. I want to stress a few things before you take this practice contest. And I doubt that I had time to go into detail about this in class, so that's another way that the videos can be useful. This is a 30-minute timed contest, so at some point here I'm going to ask you to pause, and then you'll time yourself, find some way to do that where you're sure you're working for just 30 minutes, and then put your pencil down, and then when you start the video back up again, I'll give you the answers to the contest problems, and you'll be able to figure out your score. But I want to talk about what your score means before you even get started, but by reading and commenting on these instructions. It says that you might be unable to finish all 35 questions in the 30 minutes allowed. I would change that to you will not be able to. It's almost impossible to do all 35 of these questions in 30 minutes. I took this contest myself. It took me 33 minutes. Now I was making some notes along the way to try to help me organize my thoughts for this video, so that slowed me down a little bit. But what I'm trying to say is they make this contest extremely long and extremely difficult, or progressively difficult as you get toward the later questions. They do that purposely so that they'll have a range of scores that will help them differentiate the contestants in the contest. So don't be thrown by the fact that you're not going to solve very many of these 35 questions in the amount of time you have, and don't worry about your score, and I'll explain that here in just a second. It says, please remember that this is a contest, not a test. So on a test, if you missed a significant percent of the problems, you'd be concerned. We're not expected to have mastered these problems on this contest yet. This is a contest you'll take in late February, after we've done many months of learning in class. So you're going to look at many of these problems, and you're not going to know in many of these problems you're not going to know where to start. That's okay. This is just a starting point, right? This is our first shot at this. It says there are no passing or failing scores. Few students score as high as 28 points. In the entire state, very few students, like a handful of students, scored over 28 points. And that would be 80% correct. Students with half of that, 14 points, should be commended. So they're saying 14 out of 35 on this thing is a really, really good score, and it is. So, but I don't want you to worry whatever your score is. If you spend 30 minutes on this, you did your best, you're showing your work on the scratch paper I provided. If you scored 2, I don't want you to be worried about that, because all that really matters is the next time we do this contest, the next time we do a practice run at this, if you scored a 2 the first time and you score a 5 the second time, that's a huge improvement. That's huge growth. That's 150% improvement. So that's what we're going to be looking at. That's what we're going to be focused on. So I can't stress strongly enough that I didn't give you this contest this early in the year to make you feel bad if you don't score many points. Scoring very few points means nothing at this point. Absolutely nothing. So do not concern yourself with that. It's a baseline score. It's what we'll use to compare our progress as we go throughout the year. And so as you're working on this, the problems get harder as you go. So if as you're going along you hit a problem that you're not sure how to do, if it's a contest and it's 30 minutes, you would skip that problem. You don't want to spend a lot of time working on a problem that you think is going to eat up a lot of time and you're not sure what to do. You just keep moving through the problems, find the ones that you have a strategy for, work on those, maybe come back to some of the ones you skipped if you get an idea, and just do your best. Try to solve as many as you can in the time you have. One other thing I want to say before you get started is that, I've given you a significant amount of scratch paper. Please use it, and this is the only case where this will be true. But in a situation like this, your work does not have to be neat. If you're doing a timed contest, no one's going to look at your work. I mean, I'm going to have you turn it in tomorrow because I want to see what you did, but it doesn't have to be, I don't have to follow it the way I would normally have to follow it on a homework assignment. So if you're hurriedly writing things down and trying things and scratching things out, that's perfect. That's how you should approach a contest like this. You're trying to score as many points as you can. So write down, give yourself some ideas, write some things down, try to figure out which answer choice is the best answer choice, and then put it on your contest paper and then move on. And certainly bring your work with you to class tomorrow, but don't worry about how it looks in this case. So I think I've probably said enough. What we'll do is, I forgot about this part. This is pretty important. You may use a calculator. So it's okay to use a calculator on this. Now, I know from last year, calculator is not going to help on many of these problems. In fact, there are some strategies that we'll discuss after you take the contest that if you use a calculator, it's actually going to slow you down. So I didn't use a calculator at all when I did mine. There's not a lot of computation where a calculator would be helpful, but you may use one, and when you take the actual contest in February, you'll have one next to you. So I want you to simulate the actual contest situation. So here's what you're going to do before you pause. You're going to figure out, or when you pause, you can figure out, how am I going to time this for 30 minutes? Get a calculator, get set up in a place where you're not going to be distracted, have your scratch paper next to your contest, and then go for 30 minutes. When the 30 minutes is up, you stop. Don't worry about how many you solve. Just stop at that point, and then start the video up again, and I'll go through the answer choices, and then I'll talk about what to do next. Okay, this is a good point to pause.
Pause.
Okay, I paused for a few extra seconds there. If you're listening to this and you haven't already done the 30-minute contest, please pause again and don't come back until you've done that, because the next thing we're going to do is I'm going to reveal the answers. I want you to keep track of do you see this space up here? Oh, first of all, in case I forgot to say in class, there's no place for your name on this thing. So write your name on the front cover, somewhere here near the top, so I know whose it is. Okay, and also write your name. Each piece of scratch paper you used, write your name somewhere near the top, please. Okay, now use this space at the top inside the booklet so that only you and I will see it, and then keep track of how many of these you got right, put the number. We'll look at that in a second. So the answer for number 1 was A, 2 is C, 3 is C, 4 is D, 5 is A, 6 is D, 7 is B, 8 is A, 9 is B, 10 is C, 11 is B, 12 is B, 13 is A, 14 is C, 15 is A, 16 is D, 17 is D, 18 is B, 19 is C, 20 is A, 21 is B, 22 is B, 23 is D, 24 is B, 25 is C, 26 is D, 27 is A, 28 is C, 29 is B, 30 is A, 31 is B, 32 is A, 33 is D, 34 is D, 35 is C. Now count up the number you got right, and then go back inside the booklet right here, and let's say you scored 6 correct answers. Then what I want you to do is, please, up here somewhere in the inside near the top, write this 6 out of 35. And don't forget everything I said at the beginning of this video. This 6 means nothing. Do not concern yourself with how high or low that number is. All I care about is growth. So what we care about is on the next one. If I scored a 6 here, I'm looking to score higher than 6. and there's, you know, slow, continuous, steady growth, and we're going to have some amazing scores by the time we take this in February. Okay, let me explain how we're going to finish this up. Before I do the next part, I want to acknowledge the fact that if you listen to everything I said before the contest, and you spent 30 minutes in the contest and you just graded, you've spent 40, maybe 45 minutes on your homework. That's more than enough for any one night. So I want you to hear what happens next, but you don't necessarily need to do what happens next, okay? The next part of the video, I'm going to go through some key problems and give you some strategies. If you, as you looked at some of the answer choices, if you thought, oh, how could it be B? I felt sure it was C. You may see the answer on one of these problems I'm going to do. I'm going to try to do them quickly. I'm not going to spend a lot of time on them, but I want to talk about some strategies that will give you some ideas about how to attack these certain types of problems the next time you see this contest. So what I want you to think about is, if you don't watch the next part of the video right now, I want you to please, you're going to turn this into me tomorrow. I'm going to take a look at it and give it back to you the next day. I want you to follow up and come back to this video. If you don't watch these explanations of these problems right now, come back with your contest in hand later and look at some of this commentary that's coming up at a later date. Okay, but if you want to do that at a later time, you're welcome to end the video now. If you're going to stay with me, then here we go. Problem number 5. This is a good example of, you know, you've got a calculator sitting next to you. If you use the calculator, you're actually going to be hurting yourself in a problem like this, because the point of this problem would not be to add all these numbers and find the sum. The point of this problem would be to understand the associative property and realize that 66 and 34 is 100. And 66 and 34 is another 100. And so how many hundreds do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you understand your properties, you'll understand that you can associate and represent this as 10 100s, which would be 1,000. Okay, the next one I want to talk about is number 12. This is a good example of a problem that I would think we would have a significant difficulty with at this point in the year. Because this is actually algebraic reasoning, but it's actually systems of equations. So really, this isn't even something we would do this year, but there is a way to attack this problem. So this, given what we have available to us at this point, the sum of Sid's and Sue's ages is 30. If 8 years ago Sid was as old as Sue was 2 years ago, then how old is Sid now? This is a good problem for this type of strategy. Guess and check. What I will say though is, in a contest situation like this where you have 30 minutes, guess and check takes a bit of time, and so I may skip this problem as a strategy if I were doing this contest. But if we wanted to solve it, we would maybe make a table: Sid's age, Sue's age, and then it says we know together they add up to 30. So let's just do 15 and 15 as our first guess. Okay. Then it says if 8 years ago Sid was as old as Sue was 2 years ago, so Sid 8 years ago would be Sid minus 8, which would be 15 minus 8 is 7. And it says he's as old as Sue was 2 years ago. Well, Sue's 15, so 2 years ago, Sue minus 2 would be 13. 7 does not equal 13, so that can't be our answer. If 8 years ago Sid was as old as Sue was 2 years ago, that tells us that Sid is older than Sue. So let's increase this 15 to, I don't know, 18. And but their ages have to add up to 30, so Sue must be 12. 18 and 12 is 30. Now, 8 years ago, Sid's age minus 8 would be 10. 18 minus 8 is 10. 2 years ago, Sid would be 12 minus 2, which would also be 10. And since 10 equals 10, these are the correct ages. So how old is Sid now? 18. But that might require a few more lines than what I did. I kind of knew where I was going with it. But the algebraic approach, at the risk of making this video too long would be to assign, if Sid and Sue named and start with both with S, we would just use the first letter of their name maybe, but in this case I'll just use X and Y. So this is X minus 8, this is Y minus 2. We know X plus Y equals 30, their ages equal 30, and we know that X minus 8 is equal to Y minus 2. Sid's age 8 years ago is equal to Sue's age 2 years ago. Then we use, in this case I think I'd use a substitution method. So I would isolate X. None of this is meant, you're not expected to know how to do any of this at this point in the year. I just want to show you the most efficient way to solve this problem. I would add 8 to both sides. Negative 8 plus 8 is 0, so I just have X is equal to Y. Negative 2 plus 8 is 6, so Y plus 6. So if X is Y plus 6, I can substitute Y plus 6 for X. So Y plus 6 plus Y equals 30. Y and Y is 2Y. 2Y plus 6 equals 30. Subtract 6 from both sides. I know you've done some of this, what we're doing right now, last year. 30 minus 6 is 24. 6 minus 6 is 0. That's why we did it, to get rid of this constant term. So we get 2y equals 24. Divide both sides by 2 and you get y equals 12. And once we know that y equals 12, we can figure out that x is 18 and solve the problem that way. Problem number 14, Bedeburg's bus lines are numbered starting at 33 and ending at 66, counting by threes. How many bus lines does Bedeburg have? Now, this problem is a perfect example of the more you do these type of contests, the more you'll recognize certain types of problems, because there's a little bit of a trick to this problem, but I'm aware, I knew it right away because I've seen this type of problem many, many times. So your experience taking these practice contests will put you in a position to recognize certain problems, like the very first one we did, number 5. When you see a situation like that where it's easy, the easiest solution is to associate, you'll just see that problem and say, oh, I know what I need to do here. Same thing here. One mistake a student could make would be to subtract 33 from 66. 33 and say, well, if I'm counting by threes, that's 11. 33 divided by 3, and choose answer choice D. But if we actually made a picture, so draw a picture is a good problem solving strategy. Draw a picture. If this is the bus stop numbered 33, this is the bus stop numbered 36, 39, 42, 45, 48, 51, 54, 57, 60, 63, 66. If you count these, you'll see there are actually 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because it includes this first one. That's why it's one more than 11. If these numbers were too far apart to make it reasonable to actually draw the picture and go all the way up to 66, you could use a strategy called solve a simpler problem. Solve a simpler problem. Let's pretend we're going from bus stop 33 to 39. We know that if we subtract, that's 6, and 6 divided by 3 is 2. But if you just draw this little part of the drawing, you see that there are not 2 stops here, there are 3. And that will clue you into the fact that you need to add 1 to this quotient to get the total number of bus stops. Problem number 15 is a good example of the type of problem where you can use the answer choices. We don't do a lot of multiple choice, true, false. We do a lot more application and critical thinking, and so one strategy that could elude us if we don't do this type of practice is realizing that if we have a problem and answer choices are provided, sometimes we can use the answer choices to solve the problem. In other words, if I didn't see this A, B, C, D, if I just read this, 2 numbers have an average of 10 and a product of 91. The smaller of the numbers is what? If I was going to do this, I would start with 91 and do prime factorization, I would figure out it's 7 multiplied by 13. But if you just look at the answer choices, which two numbers here would have a product of 91? Which two numbers can you multiply together? 7 multiplied by 9 is 63. 9 multiplied by 11 is 99. 11 multiplied by 30 is 143. You just keep trying to multiply different numbers together. 7 multiplied by 11 is 77. 7 multiplied by 13 is 91. And then right away you realize, okay, here are my two factors, here are my two numbers. And then you have to ask yourself, do they have an average of 10? If we're on number line, 10 is here. 13 is 3 more than 10. 7 is 3 less than 10. So they will average out to 10. We're going to talk, when we get into data and statistics, talk about that, the conceptual, what mean or average means conceptually. But these do have an average of 10, and their product is 91, and the smaller of the two numbers is 7. Problem number 17. This is the perfect type of problem for make a table. We're going to talk about ratio tables. If a faucet drips once every 5 minutes, so drips, we're comparing the number of drips to the time. So 5, oops, no, not 5. 1 drip drips once every 5 minutes. So if it drips once every 5 minutes, we want to know how many times it drips in 24 hours. So first I know I need to go from 5 minutes to 60 minutes, because that would be 1 hour. What do you multiply by to get from 5 to 60? It's times 12. So if it drips 1 time in 5 minutes, it drips 1 times 12, or 12 times in 60 minutes. 60 minutes equals 1 hour. So if we want to know how many drips in 24 hours, we need to multiply by 24. 1 hour times 24 is 24 hours. 12 drips times 24. 12 times 24. Here's a good place to use substitution and association, because I know 24 is 12 times 2, and I know 12 times 12, going too fast. I know 12 times 12 is 144, doubled is 288. So 288 drips in a 24-hour day. So that's answer choice D. Problem number 19. What is the average of all odd numbers between 20 and 50? This is a good problem for a number line. So if I have 20 here and I have 50 here, the distance between 20 and 50 is 30. So the halfway point would be half of 30 is 15, added to 20 is 35. So if I were, I'm not going to show every single odd number, but 21 is here, 23 is here, 49 is here, 47 is here. The point is, half of these odd numbers are less than 35. There's a bit more to it than that. This problem is going to make a lot more sense when we get into mean, median, mode, range, but there are equal number of odd numbers to the left of 35 as to the right of 35. And in other words, 21 is 14 away from 35, so is 49. It's 14. 49 is 14 more than 35, 21 is 14 less. So these really balance out. All of these numbers are going to balance out, and we're going to find that our average is 35 without having to do any kind of calculations at all. That would just slow us down. If we understand what the mean or the average means conceptually, we can balance this out and understand that our average is 35. I believe this might be the last problem I want to talk about. Make sure before I say that. No, there's one more after this. Number 26. At least how many 2x2 uncut, here's the key word here, uncut tiles must Pat use to cover a 7x7 section of large floor? This problem is testing your ability to read carefully. Because we know if we have a 7x7 square floor, 7 by 7. We know the area is 49 square units. We know the area of a 2 by 2 tile is 4, but we're not going to do 49 divided by 4 and figure out it's 12.25 and say, okay, we need 13 tiles. That's one of the answer choices, but that's the wrong choice. And here's why. We're not allowed to cut these small tiles. We just have to lay them down. Here's a 2 by 2 tile. Here's another 2 by 2 tile. Here's another 2 by 2 tile. Right, so when we lay 3 horizontally, we're not quite at 7. We need one more. I didn't draw it very well proportionally, but we need one more to cover that floor. And in the same way, we're going to need another 2 by 2 tile here to make 6 units vertically, and then we need one more to go more than 7. So I'm going to end up with a 4 by 4 arrangement here, which would be 16 tiles. So that's why the correct answer is D on that problem. But the reason I wanted to do this problem is really to emphasize this. You have to, in a contest situation like this, you're working quickly, but you also have to be reading carefully at the same time. Okay, this is the last problem. I'm afraid I did maybe one too many, but this is another example of use the answer choices. The sum of the positive factors of my number is less than twice my number. My number could be which one of these choices? I mean, I feel like in this problem you're forced to use the answer choices. We're going to talk about finding all factors. I use a specific method called the UT method. So I take my number and I make a t. I put it above my t, and then I know 1 is always a factor of any number. So 1 multiplied by 12 is 12. And then after 1, I check 2. 2 is 12 divisible by 2. 2 multiplied by 6 is 12. 3 multiplied by 4 is 12. And since I already have 4 here, I have all my factors. Here's the u, and the reason we call it ut is because there's the t and there's the u. And so I can start at the 1 and I can list 1, 2, 3, and then follow the arrow to 4, 6, and 12. So these are all the positive factors of 12. It says the sum of the positive factors. So if I add these all up, 12 and 6 is 18, and 4 is 22, and 3 is 25, and 2 is 27, and 1 is 28. So that sum is less than twice the number. Well, 12 doubled is 24, and 28 is not less than 24. So that rules out that answer choice. Let's do 16. 1 multiplied by 16, 2 8s make 16. 3 is not, 16 is not divisible by 3. 16 is not a multiple of 3 because 6 plus 1 is 7, and 7 is not a multiple of 3. 4 multiplied by 4. The 16 is a perfect square. That's why we see this number duplicated in this factor pair. We make our u, and we follow from the 1. 1, 2, 4. We don't need to repeat the 4. We've already written it down. 8, 16. The sum of these would be, I'm going to associate here and here. 16 and 4 is 20, 8 and 2 is 10, so that's 20 and 10 is 30, plus 1 is 31. Is 31 less than 16 doubled? 31 is less than 32, and so there's our answer. Okay, that does it for this video. I'm thinking that was pretty long, so I'm thinking many of you are probably watching this on a different night than you did the contest, but that's okay. We're just it's just a good opportunity to take a look at some of the problems that we wouldn't otherwise have time to work on in class. So I appreciate you taking the time to use this resource. I'm very much looking forward to our next opportunity to practice one of these contests, because I'm looking forward to charting the growth. I'll keep track of the growth of your scores as we go through these contests. So thanks for your time, and I'll see you.